Hello, thanks for inviting me to present Heavelock Solutions. We are a specialty consultancy company based in Trondheim, Norway, and we have developed an advanced tool for downhole pressure and flow simulation. We use it in a novel way to help our clients who plan to drill and complete wells from floating rigs. We're really good at telling exactly how the end of your drill string or completion string or liner casing behaves in relation to the heaving rig. Here is a classic illustration of a surgeon swab. On the left-hand side, you can see a rig moving down together with the drill or completion string in the well, causing surge. This can damage the well and influence its future productivity. On the right-hand side, you can see a drill rig moving upwards together with drill or completion string. This can swab in a kick or collapse the hole. You would say that your heave compensator prevents surgeon swab, and all modern rigs are equipped with heave compensators. But the problem is that every time you set slips, which happens every 10 to 30 meters, the heave compensation system is disabled and surgeon swab is a fact. This is an illustration of a rig heave limit that you normally have when you're about to drill a well. The depth in the well, the measured depth is on the left side, and the rig heave is illustrated with a straight line. And it's normally a static heave limit. It's fixed throughout the well. It's between 2 and 3 meters single amplitude, and it depends on the abilities of the rig heave compensation system. Now, what we do is to calculate a dynamic heave limit that is tailored precisely to your drilling and well operation. It's tailored to your well. Here there is an unrealized opportunity. If your well can tolerate more rig heave than your static rig heave limit says, then there is an opportunity to continue drilling or continue with your well operation. And there is also a risk if your dynamic rig heave limit, the well-tailored rig heave limit, is smaller than the rig heave limit of the rig, then you should be careful and you should manage this risk. This is a surgeon swab during connection in the North Sea. Here we have measured bottom hole pressure, the blue line, and our simulation with the dotted line. You can see that our simulation follows the measured MWD data really well. The connection time is around 300 seconds on the x-axis, a pretty normal connection time. And on the y-axis, you can see the pressure. So the pressure drops from 180 bars to about 165 bars here in the beginning when the pumps are turned off. This is called an ECD drop. And then there are no variations in the bottom hole pressure for a while, but then there are quite big pressure variations, big surgeon swab there in the middle. This is a long extended reach drilling well. So in the beginning of the connection, when slips are set, the friction in the well will prevent the drill string from moving. But the movement of the rig in heave overcomes this friction, and finally you have the surgeon swab in the middle there. And you can see that the magnitude of the surgeon swab is actually larger than the ECD effect. So this is what you will limit the rig heave in this instance. And we've done a lot of the studies, and we've written a number of SPE papers, and you can see the references below. So based on this kind of simulations, we calculate the first surgeon swab at many different well depths and for many different well operations. And then from there, we'll calculate the rig heave limit at many well depths and for the different operations. And here you can see some of the examples of dynamic rig heave limits we have calculated. You can see that they're all very different. They vary from maybe 1 meter to around 6-7 meters. And they vary for the different well operations, for drilling, for completion, for running liners casings. They will be very different in the same well. And also the rig heave limit will be very different depending on where in the well you are. If you're in the beginning of the well and there is little friction holding the drill string in place, you will have a lot of surgeon swab with rig heave. Further down in the well, you might have less because the friction of the well holds the drill string in place. We account for all of these factors. We account for elasticity of the drill string. We account for friction factors in the well. We account for the non-Newtonic fluid properties. We have a very advanced dynamic simulation, and it's a mechanic hydraulic simulation. We've helped a number of customers in Norway over the past few years. For example, companies like ONS, Shell, Equinor, and also the rig company Odfjell Drilling. And we also helped a number of customers abroad. We have helped Equinor on the Bacalhau field in Brazil, and we are now helping Beach Energy when they're going to drill wells in the Otway Basin. So every time you are planning to drill a well from a floating rig, and you suspect that the surgeon swab can be an issue due to the tight pressure margins, it can be an PHT well, or extended drilling well, or simply a well where pressure margins are depleted due to the depleted field. Please get in touch with us, and we can see if we can help you. Thank you.